Okay, our session is being recorded. This is week 11 of Data640 for the summer 2015. Now, this week we want to say a little bit about, and that's really all I can do is say a little bit about, because I can encourage you to watch a couple of really fascinating videos. But I want to say a little bit about text analytics. You're going to get more of this when you get to Data650, which is all about unstructured data, big data, things like that. So this is where text analytics belongs. But I thought it'd be good to give you a little precursor, a little heads up. And of course, one of the things that I wish we could do more of would be to do some SAS exercises with text analytics, because SAS does have a capability. Now, all software companies are struggling with getting a handle around how to do text analytics. Think about it. We've got social networks, we've got Facebook, we've got Twitter, we've got all these chat rooms going on, and there's so much text flying around. And you can glean a lot of information from that text if you had some way to get your head around it, because there's so much of it. I know there's organizations that assign people to watch the Twitter feeds and watch the Facebook postings as best they can, see if anything about their company is being said, pro or con. I think Comcast and Time Warner are two of those that do that. But there's so much out there that it's almost impossible to say we're going to just try to watch for all of it. So we're collecting a lot of this stuff. Certainly Google is, certainly Facebook is, certainly Amazon is. And the key is now, how do we analyze it? And every organization is probably collecting a certain amount because they get it through the surveys, they get it from customer feedback, they get it from other devices. So what are you going to do with it? Well, that's the question, right? So I'm going to say a little bit about some areas here. Again, this is mostly informational. You'll hopefully have an opportunity downstream somewhere to try and do some text analytics. So after we cover a little bit of the background, I'll give you a brief look at what SAS does. The best way to learn what SAS does with text miners is to watch the video. And I'll mention that later. Okay, so what is it we're trying to do with text? Well, we're trying to say, first of all, what's being talked about? Who's saying it? Where are they? What are they talking about? What time are they saying it? When are they saying it? Equally important would be, okay, what are the concepts being discussed? Is it Iran? Is it Donald Trump? Is it the price of oil? Is it what kind of shoes you want to buy tomorrow? Well, wait a minute, I'm really interested in that shoe one. If you're a company selling shoes, right? And then, of course, what's the sentiment? Are you positive or negative? Are you saying don't ever buy those Nike shoes? Or are you saying, yes, get out and buy those latest Nike shoes? So you have to not only capture the words, but you have to try to figure out the context of what's being discussed and the sentiment. I think that's tough. You will note that many of these slides come from this book, and you'll note that one of the authors is Mr. Elder, same character that wrote one of our textbooks, of course. He does have a great book, Practical Text Mining and Statistical Analysis for Non-Structured Text Data Applications. Whew, mouthful. I know it's 2012. If he comes out with a newer version, I'll probably buy it. I was going to buy this one, but I just had an excerpt from it and some articles by Elder. I'm a big fan of Elder, big fan of Abbott, big fan of Siegel. As you know, big fan of Fern Halper. And by the way, before I forget, she just did another riveting, I think, webinar talking about how to make advanced analytics easier. And she talks about many of the same things that we've talked about, automating more of it, okay? Next week, I'm going to really surprise you with what SAS is coming out now, because it's pretty interesting. I hope we'll have access to it. I've asked, but whether we'll have access to it for this class, I don't know, but I'm hoping they'll let me have access to it. It's a new product. It just came out this month, so that's the tease for next week. We'll talk about a lot of things next week that are really interesting. Deep learning, fascinating. I spent all morning watching a couple of deep learning videos to get myself, again, energized on that. IBM Watson Analytics, not Watson that won the challenge on Jeopardy, but Watson Analytics. I'll say a little bit more about that tonight. Okay, so these are the key hard things to do, aren't they? Very difficult. Very difficult. And so this has now evolved into 7 distinct text mining practice areas. Again, right out of the Elder book. search and information retrieval, okay, which is indexing, searching, and retrieving documents with keyword queries. Well, that we can do, can't we? Document clustering, grouping similar documents into clusters. Now, of course, that's doable based on, well, all these documents look like they have Canode's name in them, or all these documents look like they have Mary Jane's name in them. But we want to be able to cluster them based on style. We want to say, well, oh, Canode and Mary Jane both write the same way, so they can be grouped the same way. Their document style is similar. So that's a little tougher clustering, obviously. Okay. Document classification. Okay. Now we have trying to assign labels to untagged documents. So then we can do what? Well, retrieve them later on, and maybe do more than just retrieve them. Maybe do more than just cluster. Maybe turn them into predictive models. When I was at my SAS training 2 summers ago now, the last day in the last hour and a half of a week-long course, they showed us the SAS Text Mining. I could have watched it for much longer, but they were able to actually take an extensive collection of documents and convert it into a vector, numerical vector. Very fancy footwork went on behind it, because first you had to aggregate terms and get rid of synonyms and get rid of connector words like and but and the, and you had to go through all that. And then you had to figure out a way to turn that into a numerical vector, because as you know, all predictive models have to have numbers in one shape or form. So, you know, it was very interesting, although at the time I certainly was not sold on the concept of saying, oh, this is the final result. I know there's a lot more work to be done, but interesting. Web mining, again, documents typically presented in a challenges. Web becomes more ingrained. Remember, this is from a 2012 book. Information extraction. Now we're getting into tough stuff. Okay, we can retrieve it, maybe we can cluster it, depending on what you want to cluster it on. Maybe we can tag it. But now if you want to extract information, extract structured data from unstructured text. You know, somebody posts something on Twitter that says, you got a great pair of Nike shoes that regularly sell for $200 for $140. We would like to extract the fact that they bought an expensive pair of shoes, but they got a substantial discount, and get those numbers and be able to link them somehow. Pretty tough. Training and tuning of an extract system requires a large amount of effort and specialized software. Now the software is coming, just like everything else. It's going to get better and better and better. In fact, one of the things we've kicked around briefly at UMUC is what happens when you graduate from this program, because within a couple of years you're going to need a refresher of some sort. So we need to provide some way to bring back our grads, our successful grads, hopefully, and keep them up to speed, because continual learning, continual education in this area is definitely going to be a must. This is not easy. Natural language processing. Again, there's been, you know, that's an area of artificial intelligence, NLP, been around for some time. Being able to parse language and understand what's being said, not just recognize the words and turn it into another language, but to understand meaning. That's tough. That's tough. You know, Siri, Cortana, and these other little bots that we all have on our phones and all, they can do some of that. But again, they have difficulty with context. They have difficulty with follow-up conversations. If you say, Siri, what time is it? Yeah. Is that when I usually eat? Yeah, maybe she could say that. What time did I eat yesterday? She can look that up. But if you start getting into any kind of contextual thing, what was that again? Or what was it? Did I like it? I mean, it gets tougher and tougher. Okay? Whereas we as humans don't have too much trouble carrying on a conversation. Concept extraction. Remember, I mentioned that was one of the things. It says that's both the easiest and hardest of the practice to do. I think it'd be one of the hardest. Okay. So there's some work going on in all these areas. This is a great Venn diagram, again from the same book, showing how it sort of all has some overlap. Okay, there's other things. There's library sciences, computational linguistics, artificial intelligence, machine learning, data mining. Look at all these things. And so here are the 7 areas here in the circle, but look at all the extra overlap there is. And look how big the stat is. Stat's big in this area because you really have to attach probabilities to almost everything. Now I thought this was another great chart. Where do I start? Where do I start? Remember what this is? It's a nice little flow chart. Okay, you could call it a rule-based expert system, not one built with machine learning, one built by hand, of course. Are you interested in results about individual words? Documents, words. You want to identify, if you're talking about words, you want to identify specific facts, gain understanding. Is your focus on the meaning of the text? If it's on the meaning, we're down here where the hard part is, I think. Concept extraction. Okay, well, it's a little bit easier if you just want to extract information and not concepts. Oh, nice little flow chart. Some good place to start. This might do you some good when you get into, I'm not sure what's covered in Data 650. We've only taught it once this semester, and so I'm not sure how that course evolved during this semester. You all will be in there for the second iteration in the fall, and so this might be of some value to you. Give you a little heads up. Now, another good chart. What tools do I use? Well, we recognize a lot of these tools, don't we? Logistic regression, naive Bayes, K-means for clustering, neural networks, K-nearest neighbors. We recognize many of these. Decision trees, neural networks. You can see they've sort of given you a little template again as to which tools, can't use them directly the way we've been using them, of course, but which tools could be used with some tweaks and some different approaches for some of this. How good would they be? Well, that's a little tough. Regression is even in there. Interesting. This might be a great book. I'm not sure what book's being used in 650. Now, on the SAS. What does SAS do about this? Well, believe it or not, it has a text miner node. My understanding is we don't have access to that. Of course, I've been surprised before. I don't think anyone's tried it in this course, but I don't think we have that operationally used in the on-demand version. But this is what they showed me when I went to the training. And it has the parsing and exploration aspect built in. So you can do stemming. Stemming is where you basically pull out the key part of the word. We all remember the days in English when we made multiple words with the same stem, because that was the guts of the word, and we added prefixes or suffixes to the word, or plurals or something. So the stemming basically does the reverse. Gets rid of all the junk and says this is the stem. Recognition of multi-word terms, normalization of entries, dates, currency, percentages, all done automatically. Parts of speech tagging. I used to be good at diagramming sentences. Verb, adverb. Extraction of entities. Now we're talking about pulling some things out. But notice these are pretty easy to pull out. Organizations, products, SSN, time. Very objective things. Support for entities. And certainly language-specific analysis for certain languages. Now, what it does, what the text miner does is basically sets up the data for predictive mining. If you go watch the video of the SAS demonstration of predictive mining, it will be dazzling. Dazzling. It's a short little video. If you haven't already watched it, you really need to do that. I'm sure I have the link to it in the guidance for the week. I'll put it in the announcement about this lesson, but it's far and away the best thing to watch if you want to see how that works, because they go through a great example with a tremendous payoff and show you exactly how it works. Tasks that it can do: filter email, group documents by topic, route news items, cluster analysis of research papers in a database. That's pretty useful. Cluster analysis of survey data, cluster analysis of customer complaints and comments. That sounds useful, doesn't it? Predicting stock market prices from news announcements. That's what we want. Predicting customer satisfaction, customer comments. Predicting costs based on call center logs. These three I haven't seen as much, of course, success with. Certainly the clustering is valuable and would be nice. So again, go to this tutorial down here. Let's see if I can open this up right now. This was a really interesting website. The Little Dumb Doctor tutorial. And, you know, it actually turned out to have a reasonably good demonstration of how text miner works. Okay. So again, strange name. It's an older version, obviously here, but still the concepts haven't changed much. And so if you want to go read in great detail here, now, as I said, I'm pretty sure we don't have access to the text miner node. If someone finds that it does work and wants to try it, that would be another option for your final project. An assessment of how that works. I do not believe we have that. I was told we did not. I haven't pursued it because we didn't have time much. We did very little of this. We just thought about it a little bit last semester. Same way we're thinking about it a little bit here. So, again, text mining analysis, practical methods, examples, and case studies using SAS. Again, another good source. So the file pre-processing, SAS document from your document collection, we talked about that, initial step, decomposes textual analysis and generates a quantitative, that's the key, representation suitable for data mining. Remember, if you're going to do data mining, you need to represent words as numbers, some sort of a vector based on how many times certain words are mentioned, the importance of certain words. It's very, very soft. It's an art more than a science. The software will do the science part, but the art is figuring out exactly what you want to do. Again, watch the demo. Transforms the quantitative representation into a compact and informative format. That's where we end up with the vector, and then you can do clustering or classification. Okay? So here are the steps in the text mining process flow. Collect the data, parse it, filter it, transform it, okay, and then text mining. So it sounds great, doesn't it? As I said, I did not, the demo is great. I still think it's got a long way to go, but I think SAS is probably further along than almost anyone. It's hard to say. Organizations sometimes keep these things close hold until they're ready to announce it, but I'm sure IBM, I'm sure Amazon, I'm sure Microsoft, I'm sure some of the other big players are also working on it. Google certainly. In fact, next week, I'll mention it tonight. If you haven't yet installed the world's greatest app, it has to be Google Photos. I know there's Picasso and there's Shutterfly and there's all kinds of places to store your photos. About 6-8 months ago, when Google announced that they had a piece of software that was able to recognize cats on the internet, maybe you saw that. And you thought, well, what in the world? Why would you waste your time trying to recognize cats? Well, what Google did was train that software using their proprietary algorithms on millions of pictures of cats. And it got so good at recognizing cats, not from looking at the captions, but from looking at the actual image, the pixels in the image, that it could differentiate almost 100% of the time, 99.99%, a cat from a dog. Now, you know, they look a lot alike. Certain cats look a lot like certain dogs look a lot like certain cats, shape-wise and everything. But if you ask that Google algorithm to find you a picture of a cat, it is not going to bring back a picture of a dog. So when that happened 6 months ago, we all go, well, that's kind of interesting that it was trained, and automatically trained, by the way, just kept looking at pictures and figuring it out based on the algorithms, of course. That's kind of interesting, but what value is that to me? Well, about 3 or 4 months ago, maybe less, Google came out with an app called Google Photos. Free, works on Apple or works on Android phones, and works on your computer. It's a free app, and what it will do is upload every photo you have. Now, I have over 13,000 pictures that I store on a hard drive from years of taking pictures, and of course, put them on there and worrying about them, the hard drive crashing someday, and trying to get some of them in the cloud and saying, oh my gosh, it takes forever. This thing loaded all 13,000 up in about 4 hours, right from my computer. Once I told it they were there. You say, well, big deal. I got a photo storage thing myself. No. I can go in. First of all, it's unlimited free storage. Okay. Secondly, I can go from any device, phone, tablet, computer, and pull up any picture I want to see. I can say kids. I can say dogs. I can say a date. I can say whatever I want, and it will pull it up. And again, it's not doing it from captions because most of them don't have any captions. 99.99% of them don't have any captions. Pulls them right up. Is it correct all the time? I'd say it's 95+% accurate. It will also, you know, you can store videos also. It will create, if you go on a trip, because my son did this last week. He went on a couple weeks ago. He went on a trip from his home in North Carolina to Hilton Head to Myrtle Beach, back to North Carolina. Create the little photo album. Said, oh, I see where you were last week. I'm going to put all those pictures in an album for you. So, interesting app when we get that. Best app I ever saw. But what's fascinating to me as an AI researcher, of course, is that Google has been able to take and leverage the ability to do photo recognition of cats and turn that into photo recognition of anything. So once they figured it out, So that's, my point is that's likely to happen with text analysis. When one of the companies figures it out, one of the big guys figures it out, you're likely to see an exponential increase in our ability to do text mining. And that's going to be a big jump. And so you have to be ready for those things. Remember, crossing the chasm, we talked about that. You may not want to go yet. You may not want to invest a lot of money and effort in text mining today, but you better be ready because once there's a breakthrough or two, and that could happen at any time, you want to be ready to jump on board. Okay, so we've seen this diagram before, partition the data, and then they do text parsing, text filtering, text topics, and then a decision tree, and then a score. I'm not sure exactly what this was, but here's the link to it. Okay. Now, the case examples, there were a couple of interesting ones. Again, from this book, or this source. Hospital post-treatment survey to identify the factors you might need to recommend the hospital. Hospitals will be interested in that. All companies are interested, aren't they? We all get surveys as soon as you're done with something. Right away. Fill out a survey. Fill out a survey. Tell us what we did right. Tell us what we did wrong. Tell us where we can improve. Tell us how well we did. Tell us how poorly we did. And then another one, a large travel stop company observed significant improvement in predictive models using customer responses. The red is using just numbers. The green is using numbers and text. You can see quite a bump. We're familiar with the ROC curves, and that's quite a bump in the area covered, okay? So, you know, a couple of very good examples. This is out of a book, so I can't really give you a link to it. So 3 emerging trends. Of course, handling big text data with multiple processors. And again, here's a great link because SAS, as we'll say a little bit more about next week, has the ability to use multiple processors to handle extremely large data sets. I think I may have mentioned it already. I saw a little video, and I'll put a link to it out there, where they were looking at 1 billion with a B records for risk analysis for a bank every night. No problem. Again, because their software is able to divvy up the workload and parse it out to multiple processors and then piece it all back together seamlessly. So, of course, this multiple processor thing is one of the trends we'll say a little bit more about next week. The next couple of things, voice mining. Just like we're mining text or trying to, or moving along on that, people would like to mine voice. And just like I mentioned, they'd like to mine pictures. Okay? And so those are things that are coming too, because all of that is part of the unstructured text. Remember, we have about 80 to 85% of all information out there is unstructured data. It's pictures, it's movies, it's text, it's songs, it's sounds, it's recordings. And in real-time text analysis. Now, we can do text analysis. I told you it isn't great, but it's pretty good. It's getting better. We can do it, but we can't do it real-time. Real-time, I mean, you're watching the text as it unfolds and being able to make sense of that and or implications and or predictions and or clustering right away. And, of course, you could add one to this. You could say, how about mobile text analytics? Okay, some survey data. I'm a big fan of surveys, as you know. This is from Altiplano, 2014. What are your primary applications where text comes into play? Again, customer experience. Customer experience. And you can see how all of these have grown from 2000. They do the survey every 3 years. 2 or 3 years, 9, 11, and 14. So I'm hoping they'll do another one shortly. But you can see how there's been some growth in most of the areas. Okay, not all of them. Big growth in using the customer, from about 30% up to about 40%. Growth in research, brand reputation management. Oh boy, that's a biggie. And then down here are some smaller ones. So very interesting survey. Again, you can go get this. It's very interesting, especially if your company is interested in text analytics. So you can see insurance and fraud, small, lightweight ones down here, but the big ones are up here. Competitive intelligence, knowing if your customers really like what they saw and did, those kinds of things. What textual information are you analyzing or do you plan to analyze? Blogs. Blogs are big. News articles, comments on blogs, customer surveys, online forums, Facebook postings. Of course, that's the new one because there wasn't any Facebook when they did the surveys before. And then a lesser important scientific and technical lecture. Email, you can see falling off. Why? Because we don't send much email anymore. It's all blogs and tweets and things like that, chat and so forth. So another interesting thing, if you're interested in where the trends are, what we're going to be looking at. How do you measure ROI? Isn't that an interesting one? Because again, it's not easy to measure ROI on anything, and it's even more difficult to measure ROI on text mining. Say, oh, I feel better about our customers now. Or, look, 90% of our customers like us, 10% don't. We could have gotten that without much text mining. Okay, so higher satisfaction ratings. Again, you can see the right now measure, achieved, and plan to measure. Big things. Increased sales, ability to create new products, higher customer retention, improved customer acquisition, reduction in required staff, and so forth. Interesting. A very interesting survey, because I like surveys like this. Please rate your overall experience with text and content analysis. Okay. Overall experience satisfaction. Well, there's a big chunk in here that seemed pretty satisfied. Okay. A small chunk that's very satisfied. A lot of some neutral. And of course, if you look at the ability to solve business problems, there's still a big chunk that are pretty satisfied. Solution technology, ease of use, surprisingly, still a reasonable sized chunk of people that are satisfied. Less than half, but 40%, 39% say, it's not too bad, the tools. Technology performance, again, pretty good numbers. Accuracy of results, quite a bit, although we're starting to get a substantial amount of disappointment and very disappointed. So 25% of people say, nah, it's not working. 20% are neutral. So almost half the people are saying, not really getting what I want. Availability of professional services, well, of course, we really don't have a lot of consultants out there yet doing text mining or a lot of companies providing that, so it's pretty much in-house. And, this reflects that. I was actually surprised at how much positive information is in here. I would have thought that the disappointed pink bar would be huge on all of these things. Based on what I've read, what I've seen, I have not been as excited about it. What is important in a solution? Those generate categories. Well, that's one of the easier things, or taxonomies. Document classification, ability to use dictionaries, extract information. Low cost, not so much. Multiple language, not so much. Open source, predictive analytics integration. You can see this one hasn't really, basically, I think companies are still the reason they're satisfied is they're really looking at the early things you can do, the clustering. If you can find out what your customers group into people who like you and didn't like you and why, that's pretty good. If you want to use it to predict something that's going to happen based on text, that's tougher. Just like we saw the growth in predictive analytics with numbers. Everybody started with just information visualization and dashboards and everything. What is happening? And everybody was happy with that until they started realizing that some companies were getting into what is likely to happen next. Same thing here. Right now, companies are pretty well satiated if they can at least say, here is what is happening. Percentage-wise, here's how the sentiment is running, for and pro and con, just almost like we do polls for elections, But soon people are going to say, I'd like to take that text and predict what people are going to do next with their money, or predict what they're going to do next in terms of churning or leaving the company, or predict what they're going to do next in terms of committing fraud or something. So I think you're going to see some growth in these bottom numbers. Now, again, this is probably the best demo right here, because this demo, which, oh wow, that got loud. Sorry. Okay, you want to look at these demos. The Tech Talk video is good. The analytics software demo is good. And the active money. These are all very, very good. Okay, this one is the best example of SAS Text Mining in action. It's got the asterisk. So again, these are your sources if you want to see it in action. And you'll be impressed. I think you'll have to be impressed. Okay, so short lesson tonight. Now, what is it you're supposed to be doing in week 11? Well, week 11 is, as you know, our course ends August the 9th, Sunday, 2 weeks from Sunday we just had. So this is the beginning of week 11. Week 12 starts next Monday, or Tuesday rather, but the course ends on a Sunday. So we have to have all the assignments in. We have one more assignment to do, assignment 4. Okay, I have tried to provide a few options for assignment 4. Okay, before we get to that, let's just mention that next week I'm going to talk about the future predictive modeling, and I'm going to cover a wealth of very interesting topics. There is a lot going on. There's a lot going on, and the developments are happening so fast that I'm having a hard time just keeping the slides updated. And as you know, I usually update them right up until almost class time. So, there's so many interesting things that I'm finally having time to go back and look over that have just occurred recently. Listen, here is some deep learning, Watson analytics, etc. Okay, and I'm going to say a little more about that in a minute. Now, before we go to this last slide, let me show you, if you haven't already looked at it. This is the guidance for assignment 4. And I've tried to provide a couple of options. A couple of options that I think are fairly straightforward. Go get a real-world data set. And by the way, I have links to real-world data sets. And create at least 3 models. At least 3. Decision tree, regression, neural network. The 3 biggies we've covered. From the same data set. Analyze it. Again, this would, since it's a predictive data set, you can analyze it for which one's the most accurate, which one is going to be the most insights, how do they compare, kind of like we've been doing. So the same kind of things we've talked about before, descriptions of the data set, data cleansing, build the models, including transformation imputation where necessary, compare the models on the accuracy measures, any special features you did, write up recommendations. It's kind of the same approach we've had for most assignments. Now, I will allow, if you find the real-world data sets totally overwhelming, you can go get one of the UCI data sets. They're not the best choice because they've been used for other assignments in the class, and they're already fairly clean and relatively small for the most part. So again, this is a challenge, but there's plenty of real-world data sets out there that are fairly manageable. There's a lot of links, financial data, and other things. Take a look and see if you can find one that you think you can handle, because I know it can be overwhelming. So that's option 1. Option 2 would be to go get a real-world data set, same thing, and build an ensemble model. Okay, one of the ways we've talked about. We talked about ensemble model last week. We didn't really do much with ensemble models. So, you want to get a real-world data set and build an ensemble model. That's sort of another option. Same kind of thing. Describe the data, describe the model, etc. A third option, of course, is this thing called Watson Analytics. Now, I haven't said anything about Watson Analytics in this course. I usually mention it briefly in Data 610 now. Watson Analytics only been out there maybe 6-7 months. There's two confusing products from IBM. One is Watson, the thing that won the Jeopardy challenge and is being used in many, many hospitals, many banks and financial institutions. And Watson is amazing. It's an artificial intelligence entity that basically, it learned by reading Wikipedia. And of course, if you've never seen it perform on Jeopardy, you need to go watch those videos because it was going against Ken Jennings and the other guy who were the best players ever, and it slaughtered them. But think of what it has to do. That was Watson, not Watson Analytics. What Watson had to do was interpret the question, which is often vague and double entendre and everything else, find the answer, turn it into a question, and beep in before those other two characters did it. And of course, they beep in within a fraction of a second. So Watson had to do an awful lot of work. And the fact that it won so handily. So if you're interested in Watson, that's fine. That's not part of this course. But if you're interested in Watson, I would encourage you to keep an eye on it because it's one of the most interesting things I follow is Watson. Now, Watson Analytics is different. Okay, it's not the same at all. Watson Analytics, okay, and you can get a free account for Watson Analytics. You won't have the total robustness of the software, but you will have the ability to use the software and do things with it. Watson Analytics is something that IBM announced, and what it is, as it says here, a smart data discovery service available on the cloud. It guides data exploration, automates predictive analytics, and enables effortless dashboard and infographic creation. Right away, you got to be impressed if it can do all that. Now, I want you to go watch the video and see for yourself, but let me tell you what it does. The first thing it does when you upload, and you can upload a data set of your own, is it goes in and says, here are some interesting questions that I think would be relevant to this data set. Now, what is that? Well, it takes us back a little bit to 610 where we were trying to frame things, as you recall, and that's a difficult thing to do. And Watson goes through and finds 5 or 6 or maybe 7 or 8 key questions from the data set that it thinks are appropriate that you might want to inquire about or build a model around or something. But right away, you're off and running with some of the mega questions that we always had to put into things like decisions first to get started and so forth. Then it will go in and build you a predictive model. Okay? And when I say it builds a predictive model, it basically builds decision trees. Okay? Not all predictive models. And then you can turn that almost seamlessly into a dashboard. So here we have 3 really good pieces. The framing, modeling, dashboard, which would certainly help on selling and implementing the answer, right? And of course, the predictive part, since it's mostly a decision tree, would lend itself to rules right away. So, it does some clustering. That's part of the data exploration. And it does builds some other kinds of things. And of course, builds helping you tell a compelling story. Okay, that's what the graphic is for. So this is very impressive stuff. Now, we had a few students last semester that had just come out. I think we had 2 or 3 who took that option to try Watson Analytics. So what they wanted to do, and again, I'm allowing it this time if you choose, is to use Watson Analytics on one of the data sets you've already used for one of your other models and compare the two. What do you like best about SAS compared to Watson? What limitations does Watson have compared to SAS, if any? What advantages does Watson Analytics have over SAS? How do the accuracy of the models compare? There's a lot of dimensions you can sort of structure around that. We haven't used it. We haven't done it enough for me to be able to give you, as precise an instruction set for that assignment as the other. But let me tell you, it was pretty impressive. And some of them found some things it can't do, and some of them found some things it does better. And of course, IBM has a ton of money. I'm certain they will continue to improve it. So if you're going to do that, you're going to have to go get your account, your IBM account. Analytics free and easy. Okay, and it does, of course, it's doing it automatically. Now this, again, we're going to take a little bit of a look at Watson in a little more detail next week. It's one of the futures of analytics. As I see the future of predictive analytics, one of those futures is more and more and more automation of the tools. Less and less writing native code, more and more tools that are powerful and flexible enough that you don't have to spend the time writing the code. You fill in the blanks. You turn over some automation. Many of you have commented this semester, why doesn't SAS have a tool that automatically transforms based on the best transformation? Why do I have to tell it to use max normal? Or why do I have to tell it to compare this and that? Why wouldn't it just do that? Why wouldn't it automatically sort of have a default to partition the data set and all like that? And then let you change it from away from that. You're going to be interested in, as I said, the new product I'll show you next week. So pick one of those options. As I said, they're all equally valid. If you have some other, again, what you need to do is explore the Watson capabilities. Explore, predict, assemble. Those are the three things it does. Explores the data, sort of a clustering approach. Predicts, again, decision tree. And assemble, that's the dashboard. Compare the models developed in both Watson Analytics and your SAS Enterprise Miner on various dimensions, ease of use, variety of models, include any special features, include the write-up or comprehensible summary of the findings, and glean any insight, so forth. Okay, now again, a footnote at the bottom. This is only our second offering of Data640. The first one was last spring, went rather well. This one has gone better. So I'm open to any other interesting alternatives you may come up with, but I think these are three reasonable ones. Again, if the real-world data sets, if you decide to do options 1 or 2, and the real-world data sets overwhelm you totally, feel free to use one of the UCI data sets. I will say that, again, part of the scoring of the assignment has to do with, what data set did you use? Because if you pick one that doesn't require much cleaning or transformation or imputing, that's obviously easier to deal with than one that requires more of that. But on the other hand, you've only got so much time, and so you don't want to take on a data set with 50 million records and 250 variables and have to go through, sort of a career of work, a short career of work to get one assignment done. Okay, so there's a balancing act, and I understand that, perfectly aware of that. There's only so many hours in the week. Everybody has jobs, other commitments, and so forth. But, it's nice that once in a while take on a real-world data set. It's nice to once in a while say, oh, my gosh, the real-world stuff, not quite as neat, clean, and ready to go as some of the stuff we've been using in classes. Of course, you go out in the real world, that's the only kind of data sets you're going to find, right? You're going to find all data sets are messy, and all data sets need a lot of work and cleaning. So, okay, so again, there's a couple things you ought to do this week for sure. You ought to watch the SAS Text demo. You ought to go and watch the IBM Watson video. You ought to decide for yourself which of the options you're going to do for assignment 4, and then start looking for a data set. This was an article in Forbes. This is really what got my attention. You can see the date was January 2015, so Watson's been out there about 6 months. When I read this, I said, oh my God, now I thought it was Watson, the one I mentioned that won Jeopardy. Turns out, if you read behind the scenes, it's not the same package, called Watson Analytics. They may merge the two eventually. Right now, Watson Analytics. Making it possible for people in every department, finance, HR, marketing, or operations, to type in questions like, what are the key drivers, which deals are most likely to close, and get the answers they need. Wow. Okay. It's something called cognitive computing. Now, again, that's a whole separate arena. I don't want to spend a lot of time talking about that, but it's a fascinating arena. Cognitive computing, the idea that the computer is moving from being a tool to being an assistant. Some would say someday it'll be our boss. Robots and machine learning will take over, and we'll have singularity occur, as Mr. Kurzweil thinks, and so forth. Right now, though, we can definitely see that the computer is appearing to be smarter and smarter and smarter. If we ever totally decipher what goes on in the brain and can inculcate that into a piece of software and put it in a computer, look out. And of course, some of you know that I follow that kind of stuff pretty closely, try to. Okay. Data-driven insight will become an everyday part of how we solve problems, making better decisions and drive better results. Well, as you know, those of you especially who had 610 with me, I've been pounding the drums for data-driven decisions since day one. In fact, we built our whole MSBA course here at UMUC trying to say, let's continually focus on marrying decision-making and analytics. That's kind of our thing. Watson, this may scare you because you're trained to be a data scientist. Watson makes sense of raw feeds of data without needing to be a computer scientist. Ranks results based on how statistically interesting they are. So we're using some stats behind the scenes and so forth. So this is a good starting article. Here's the Forbes article. And then go watch a couple of videos and then decide for yourself. Normally, I would say I'm going to talk about Watson next week, but of course, if some of you want to get started on your final assignment, I want to give you a little precursor now. So there are a lot of Watson analytics. Make sure you type in Watson analytics. I'll try to provide some links in the Leo classroom for week 11 so you can look at those. But it's going to be big, I think. I don't think, you know, I'll reserve judgment of saying anything until you all have a chance to look at it and play with it. Okay, but it's pretty neat. All right, back to where we were. Okay, we're back now to our final slide as always. It says if you have questions, and I see one over there. If I drag the chat room over, when is the fourth assignment due? Okay, fourth assignment is due midnight, August 9th. Fourth assignment is due midnight, August 9th. That's when the course technically ends. I have to turn grades in within 3 days, 72 hours after the course ends. They don't give us any slack on that. So do not have a missing assignment past midnight, August 9th. Now, if something happens, obviously we have accommodations for emergencies. There are ways to get incomplete grades. In order to get an incomplete, you have to complete at least 60% of the course, and you have to have a grade of B or better. I think everyone in this program is at that point. I'm not going to just give out incompletes willy-nilly, but if something happens, obviously we want to do that. Now, of course, you can't take the next course until you finish, get the grade for this course. So it does slow you down a little bit. But, you know, we have the capability to handle some of that if necessary. Okay, so midnight, August 9th. This Sunday will be August 2nd. You have one more week past that. So don't take on, again, something you can't finish in the requisite time in terms of the final assignment. The ensembles are interesting. Of course, that's one option. All right, good question. I'll make sure we have all that cleared up administratively. All right, well, as always, I'm going to go stop sharing. As I said, I'll put some links out for the Watson Analytics in the week 11 area there. I remember those other links, you know, the guidance and the slides and so forth. And you ought to go look at some of those. All right, and now I'm going to stop the recording.